Dear participants, I welcome all of you in this lecture of end-to-end data science project. In last class, we discussed a project related to binary classification. In this lecture, in last class we discussed diagnostically uh, predict whether a patient has diabetes on the basis of a given data set. So we had already seen this particular project. In this lecture, we'll discuss a separate project which is actually based on multi-class classification. So the target is to recommend the most suitable crops to grow in a particular farm based on various parameters mentioned in the dataset. So the dataset that we have selected is crop recommendation dataset. In this particular dataset, a user can build a predictive model to recommend the suitable crops to grow in a particular farm. So a user can utilize this dataset for this type of recommendation. This dataset was built by combining datasets of rainfall, climate, and fertilizer data available for India. And you can download this dataset using this particular link. So it is available on Kaggle. As far as this dataset is concerned, so it is having these independent features such as ratio of nitrogen content in soil and ratio of phosphorus content in soil, ratio of potassium content in soil, temperature, humidity, pH value, rainfall. So these are independent variables, and this one is the outcome, you could say dependent variable, which is label. And this label is having different, it is actually a categorical data. It is having 22 different categories such as rice, banana, papaya, and orange, and so on. So it is having 22 different categories. Before discussing on this particular project, which is type of multi-class classification, we will discuss on confusion matrix for especially for multi-class classification, because somehow the precision and recall and F1 score would be calculated in some different way as far as multi-class classification is concerned. So in case of binary classification, like the case that we discussed in last class, that was based on diabetes dataset. So in this case, you are having only two classes, that is 1 or 0, or you could say true or false. So these are this one is the predicted class. It means suppose you have selected a model, let's say random forest, and your model has generated these values, right? So in case of 1 here, this one is the true class, right? This one is the true class. It means the actual outcome, or you could say actual dependent variable value, right? So this value 5 is actually true positive. Why it's so true positive? Because your model has predicted it positive, and it was actually the positive cases, right? It was actually the positive cases in your data set. Like in this case, your model has predicted it as 0, but it was actually 1, or you could say true, in the actual data set. So that's why it is called as false negative, falsely predicted negative. We call it falsely predicted negative. Why so? Because your model has predicted it falsely as negative. Now they come to this side, this one. So your model has predicted as false, as in false class or 0 class, and actually it was in that class in the actual data set also. So that's why it is true negative, truly predicted negative, right? Now come to this value. this is your class has predicted at positive, while in actual data set it was negative class or zero class, right? So that it is called as falsely predicted positive, right? Falsely predicted positive. So now these values I have mentioned here, right? Now on the basis of this, we can calculate recall and precision and F1 and accuracy, right? So as far as recall is concerned, so recall is true positive cases divided by true positive plus false negative, right? So this value, you can calculate this value. Similarly, precision is true positive divided by true positive plus false positive. It means the total ratio of true positive with the actually predicted positive cases. So this model has predicted this as a true, right? Your model, let's say. So precision is actually the ratio of true positive with the predicted true positive case, with the, or you could say actually true positive with the predictive positive cases, right? So this is the precision. Now in this way, binary, we calculate recall, precision and accuracy is total positive cases, right? TP plus true positive plus true negative divided by all, right? So this way you can calculate the accuracy. Now come to the confusion matters of multi-class classification. So let's say you are having three different classes A, B and C. Like in the case of crop recommendation dataset, we are having 22 different classes, right? So for 22 different classes, we will see this confusion matrix. Now these are, as far as class A is concerned, so this is the true positive for class A, and this one is the true positive for class B, and this one is the true positive for class C, right? So actually your model has predicted it as 4 as far as C class is concerned, and in the actual data set it was 4 related to class C. So that why it is true positive. Now there are different ways to find the value of precision and recall. So we follow different type of mechanisms through which we can calculate average and precision. Precision and recall. So the first that we'll discuss is a macro averaging, right? So in macro averaging, we calculate the number of true positives, false positives and false negatives for each class, right? So for each and every class, since in the previous figure, we are having 3 classes. So for each class, we will calculate true positives and false positives and false negative, right? So this is the target. After that, when we will calculate true positive, false positive and false negative for each class, then we will compute precision and recall for each class, right? In this way, how precision and recall is calculated. So we will calculate for each class. After that, we will take the average to calculate the precision and recall of the whole for the whole data set. So we will take the average. So that is called as macro averaging. This approach is called macro averaging. Let me discuss with an example here, right? So you are having 3 different classes here, right? A, B and C. Now the first target is to find the true positive, false negative cases of this class A. So as far as class A is concerned, so true positive cases is 5, right? And what about false positive, right? False positive it means falsely predicted positive cases. So the model has predicted this 3 and 1 as a class A. Your model has predicted this one as a class A. But in actual data set, this was B and C, not A actually, right? So this is called falsely predicted positive, false positive. So that's why false positive is 4. So true positive is 5 and false positive is 4 as far as class A is concerned, right? Now we'll discuss false negative, falsely predicted negative. So my model has predicted these value as B and C, right? But actually in the actual data set, this was class A, right? But my model has predicted it as a B, class B. So these are falsely predicted negative cases, false negative. So that's why it is 3. And we are considering true negative as all the cases in this case, which our model has predicted as negative. And the in actual data set, it was not a class A, right? So my model has predicted is not A. And similarly, the data set in this case is not A classes. So you can write true negative as 12, right? Similarly, you need to calculate for B, class B as well as class C. So how we will calculate? Let me erase this one first. Yes. So how we will calculate for class B? So true positive, first we will calculate the true positive. So this is the true positive for class B. Since our model has predicted it as a class B, and in actual data set it has been predicted as a class B. So true positive is 6. Now come to false positive, falsely predicted positive. Now my model has predicted these two value as B, right? These two value as a positive cases, right? But actually in actual data set, these were not B, right? So these value are not B in actual data set. It actually belongs to A and C, right? So that's why it is now we'll take some 1 plus 1 2. So these are false positive cases, false positive cases. Now come to falsely predicted negatives, false negative cases. So my model has predicted these two as negative cases, right? Negative since it is not B, but actually it was B in actual data set. So that's why it is false negative. So it is considered as 4. Now all other cases, this one, and this cases and this one, right? So these are true negative because my model has predicted not B, and in actual data set it was not B, right? So in this way you would calculate the true positive, false negative for all the classes. Now we will calculate individual recall, right, for class A. You could see here, which is true positive divided by true positive plus false negative, which is 0.625. You can consult this table for class A. So this is class A table, this is class B values, and this one is class C. Now similarly, you need to calculate recall for class B and class C, right? And finally we will take average. So it comes 0.628. So finally the recall value is 0.68. Similarly, you can calculate a precision, right? So this is macro averaging. Now we will discuss next one, that is called micro averaging. So how macro averaging works? So first you need to calculate true positive, and false negative cases across all classes. So you will calculate the false negative, false positive and false negative cases, right? Now total true positive. So now we will calculate total true positive. Total true positive. So what is total true positive? It is the sum of true positive counts across all the classes, right? So just you are going to sum all the true positive across different classes. Similarly, you will calculate total false positive across all classes and total false negative across all classes. Now we will calculate the precision on the basis of these values. No, this total positive in this case is actually the sum of all the positive cases across all the classes. Right. Similarly, you will get false positive for all the classes across. False positive is actually summing of all the false positive cases across different classes. Similarly, false negative. Now we will calculate the precision and recall. Right. So let me come to this example, the same example. Here we have calculated, false, true positive, false negative, and false positive for all the classes. Now we are summing up, right? This is the macro, how we are calculating the macro average. So true positive cases, this is the final confusion matrix. Right? So what we are doing, how we are creating this final confusion matrix. So we are summing all the true positive cases here. So what are the two positive cases? 5 plus 6 plus 4, right? Similarly, this one is false negative, falsely predicted negative. So I would calculate 3 plus 4 plus 2, right? Similarly, this case is false positive, falsely predicted positive. So which is 4 plus 2 plus 3. And this is the true negative, which is 12 plus 12 plus 15. And then we'll calculate the recall. And similarly, we can calculate the precision. So in this way, actually, we calculate and apart from these macro averaging, we are having other techniques as well. But these are very much popular. And so I will discuss these averaging in case of executing the model on agriculture data set. Let me switch to the Google Colab. So first of all, I will mount my Google Drive, right? So that I can connect to. This is already mounted actually. Now I will read the data set, that is crop recommendation data set. Now here I am trying to find out the unique label. It means what all categories I have in the dependent variable. So I want to see the different categories, right? So these are different categories in your dependent variable, or you could say an outcome. So these are different values, different categories actually. Now we can describe this data set. So in this data set, total 2200 entries are there, and there is no such missing value. All are filled. You can see here, and only the label is having. Since you can see it as an object, which is actually for categorical data, right? So this is the categorical data, and it is having 7 independent variables and 1 dependent variable. And you can see the count, standard mean, standard deviation, minimum value, and so on. So these are certain values. Now we'll try to visualize using the histogram. So this is the visualization of temperature and humidity, right? How temperature and temperature and humidity values across different beans, right? And then we'll try to find out the count of each and every categories. How many entries are there in the data set? So you can observe each and every category is having equal number of instances, right? So apple came 100 times in that data set. Similarly, banana is coming 100 times in that data set, and so on, right? So it's each and every category is having 100 instances. Now I will try to display the correlation matrix using heat map. So you can observe here there are certain red values. So diagonally, uh, it would be 1. Why so? Because it is correlating feature with itself. But if apart from these, you can observe it like potassium is very much related with p value, right? So K is very much related with P, right? So which is very much correlated. Similarly, you can go through like temperature and rainfall is very low dependent, 0.03, right? Now we can display the pair plot as well. So, but it would take time. Let me execute this one. I'm executing this one, pair plot. It's not outcome, it's label, right? So it would take some time to display the whole pair plot, because it would display the pair plot between each and every between two variables, right? So that's why it is taking some time. Once it would be displayed, so it will show the relationship between every two variables of your data set, right? So it is executing here and it would take some time, right? So yes, you can see here these are actually different. So these are in case of pair plot, I use hue as label, right? Since it is a categorical data. Now you can see here how temperatures are related with rainfall, and for different type of you can see here these values, or these particular values. Which one? This is actually your, I think, orange, not papaya. So this is the I think orange. It's very let me increase the size here. Yeah. So you can observe this one. Sorry. So this pink is actually cotton, and this is papaya. And as far as humidity is concerned, so this particular needs high humidity, right? And which is pink in this case, which is actually coconut, right? So in this way, you can go through this. It would give you very informative way of understanding the whole variables. Next, I am trying to splitting the data set. So I partition the data set into X and Y, where X is my independent variables and Y is my dependent variables. I am printing Y as well, which is the dependent variable. Now I am partitioning it in training and testing data set, right? The test size is 20%. Right? Now I'm right now I'm exploring this preprocessing. I'm directly coming to execute the models. Yes, and you can see here I also want to know the instances of different categories in testing data set, right? So testing data set is having 20%, right? And what are the different instances of different categories? Let me execute this one. So apple is coming 23 times in testing data set. Similarly, banana is coming 21 times in testing data set and so on, right? Now I will be executing logistic regression. Now, as far as the precision and F1 and recall is concerned, so I can use here averaging. So here I am using macro, that the one that we discussed, right? So macro, I can also use, so let me, I can also use macro, right? Or you can say micro. So we discussed what is micro and what is macro. Even you can use none. It means I am not going to take average. So what it would do? It would find out the precision of each and every classes. And in our case, we are having 22 different classes. So it will find out the precision score for each and every categories. So in your precision score, you will find 22 entries in this case, if average is none. And what if I am using micro? So in case of micro, I would get single value as far as precision score is concerned. Similarly, I will get F1 score, I will get single score because it is anyhow it is averaging internally, right? Similarly, I will get the single micro. As far as accuracy is concerned, so accuracy is just true positive, all the positive cases divided by all cases, right? So in this way, it would be calculated. Let me execute this one. I have set micro for each and every model, right? Now, this is the actual matrix, confusion matrix, and you can observe here since let me just a minute. So this one is the confusion matrix for logistic regression, and you can see here this is our this is true level, these are true level, and this is the predicted level. The lower one is the predicted level. It means it is the predicted value for logistic regression. So my model has predicted 23, and actually it was having 23 instances that I have already shown you, right? So the true positive is 23 as far as apple class is concerned. Similarly, as far as banana class is concerned, it is having 21 true positive. And what about the false positive and false negative? So false positive, falsely predicted positive is 0. In this case, you can see here, you can sum up all zeros, so you will get 0. And so this one is the falsely predicted positive, false positive, and these are false negatives. The upper one is a false negative, which is again 0. In this way, you can calculate each and every the true positive, true negative, false negative for each and every classes, right? In this way, you can calculate. Now, I am trying to execute. Let me execute all the models here. And how I will execute all the model? So, just a minute. Yeah. So let me. Sorry. I would try to. Yeah. So run after. So now I am trying to execute all the models. So all the models is being executed here. So it is giving me So some models are being executed here. Now it has stored this value, this file W. And let me open this file and this drive, my drive, and inside envelope by. Yes, envelope by. I would have W micro. Yeah, this value. So you could see here, these are accuracy, precision, F1 and recall. So each one is having single values, right? So name base is having maximum accuracy, right? So in this way, you can calculate using the uh, you know uh, macro averaging. If you would take here none in all cases, none. So what you will get? None. So you will get values for 22 different classes, right? 22 different classes. So precision, recall, and accuracy for all. So in this way, you can calculate. So if I would execute this one, so I will get the precision, score, F1, and recall for 22 different classes. So you will see 22 different entries in your file. So in the file that I'm storing my result. Right? So I hope it is now clear to you how binary class classification works and the purpose of confusion matrix for binary class, and how multi-class classification works, and the purpose of confusion matrix, and how to calculate precision, accuracy, recall, and F1 score in case of multi-class classification. So I'm stopping here. Thank you so much for joining the class. We will meet again in concluding lecture. Thank you so much.